if we look at this example data set from fall 2001, using standards, so using the fact that for that brown bag or that red bag the mean is 5 and the standard deviation is 1.715. So these are known process parameters. Brown bag process, red bag process parameters. We would have a lower control limit for x bar that is 5 minus 3 times 1.715 over the square root of 5. This 5 is there because that's the basic sample size. If the Deming drama had been done with samples of size 4 or samples of size 3, that number would be not 5, but would be the basic sample size used. This turns out to be 2.7. An upper control limit for x bar, a standards given upper control limit for x bar is 5 plus 3 square roots, 5 plus 3 times 1.715, that's sigma over the square root of the sample size of 5, and that's 7.3. If we look back at the plot of the means, we look at these guys and see them plotted over the period of over the 18 periods where we were drawing data. You'll notice that I've drawn in control limits for x bar at 7.3 and 2.7, and what you see is that if those standards given limits had been applied to x bars as the x bars came in, that is, if they had been applied to x bars in real time, it's not until these values that points plot outside of control limits, and it's at that point that one would have discovered that in fact no, mean of 5, standard deviation of 1.715 cannot be governing what's going on in the process beginning at sample 16. So if we go back to what I was writing here in this example, so we would say that when these are applied to the Deming drama data, we see that change from these standards would have been detected at sample number 16. To carry this example a bit further and make retrospective limits, I will tell you that you can check that if I take all 18 sample means and sample ranges from figure 1, so all 18 samples give me an average x bar that is 5.744 and an average range. So if I just add up the ranges, I divide by 18, I get 4.278, and that gives retrospective limits for an X-bar chart of, well, the lower control limit for X-bar would be this 5.744, this X double bar minus an A2 constant times R bar. And if you look on page 509, you'll find that for samples of size 5, the A2 value is 0.577. If you take 0.577 times 4.278 and you subtract that from X bar bar, you get 3.28, and the upper control limit, the retrospective upper control limit for X bar would be the same thing with a positive sign there, and that turns out to be 8.21. And then applying these retrospectively, what you find is that all three of the last X bars are all the last three of the X bars are all outside of control limits. So applying these retrospectively, one sees that the last three X bars are all outside limits, and what that tells us is that looking at these data and making a provisional assumption of process stability and then plugging the estimates for process parameters into standards given control chart limits to criticize that provisional assumption, indeed we end up determining that it's not possible that the process was stable over the period of data collection. So there is evidence of process change in the data. And that's how Shewhart X-bar charts work.